Hello teachers, learners, and parents. Sir Jeff po, at your service. Alam nyo ba na meron tayong website na tinatawag na DepEd Commons? Ang DepEd Commons ay binuo upang gawing accessible ang pagtuturo at pag-aaral dito sa ating bansa gamit lamang ang inyong mga smart devices gaya ng cellphones, tablets, at computers. Dito ay maaari nating ma-access ang iba't ibang learning materials mula sa Department of Education. Meron itong mga interactive materials, electronic self-learning modules, at instructional video lessons mula sa DepEd TV na tiyak na makatutulong sa pag-aaral ng mga mag-aaral galing ka man sa public o private school. Walang problema dahil welcome ang lahat dito. Para ito sa mga guro, magulang at mga mag-aaral mula sa kinder hanggang grade 12, alternative learning system o ALS, at pati na rin ang special education. At huwag kang mag-alala dahil kahit walang load ay maaari mong ma-access ang mga learning materials. Tama, libre ito. Ang kailangan mo lamang gawin ay i-on ang iyong data at buksan lamang ang iyong browser at i-type ang commons.deped.gov.ph. Alam na ba ng iyong mga kasamahang guro o mag-aral ang tungkol sa DepEd Commons? I-share mo na ang video na ito upang matuto rin sila kung paano gagamitin ang DepEd Commons sa mabilis at napakadaling paraan. Muli, ito po si Sir Jeff at kita-kits po tayo sa DepEd Commons. Paalam!
Magandang araw! Sir Wilbur po, at your service. Narito ang ETULay upang gabayan ka sa inyong pag-aaral upang lubos na maunawaan ang iba't ibang paksa o subject. Ang ETULay ay isang free online tutorial class na pinangungunahan ng DepEd Educational Technology Unit sa pamumuno ni Undersecretary Elaine Del B. Pascua. Ang programang ito ay hindi lamang para sa mga bata, kundi ito rin ay magsisilbing gabay sa mga magulang at mga guro kung paano nila ituturo o gagabayan sa bawat asignatura ang kanilang mga anak o mga estudyante. Sa kasalukuyan, ang self-learning module mula sa rehiyon ng Calabarzon at kilala sa tawag na pivot ang ginagamit sa ating ETULay online class. Kaya ano pang hinihintay ninyo? Ihanda na ang inyong mga ballpen o lapis, papel o kwaderno at samahan kaming itulay ang pagkatuto para sa bawat batang Pilipino. Sama-sama tayong magtutulungan para malampasan ang mga hamon sa panahong ito. Halina't matuto kasama ang inyong online tutor sa oras na ito.
Hello! Magandang hapon po sa ating lahat, sa lahat po ng ating mga viewers. Today is February 22, 2021. This is Tutor Lester at your service. And I welcome you to another session in Physical Science dito sa ating DepEd ETULay session. We are on the 8th week of the second quarter, which happens to be the last week of the quarter. Ang topic po natin ngayon sa session na ito ay ang General Theory of Relativity. Alright. Okay, so So ang ating topic po ngayon for this afternoon session is the General Theory of Relativity. Kasunod po nito, ng topic na ito ay ang how we know we live in an expanding universe. So for this session, the learners are expected to state Albert Einstein's general theory of relativity and its postulates, explain the consequences of the postulates of general relativity, and give examples where general theory of relativity was applied. Atin pong balikan ang ating paksa sa nakaraang linggo. Subukan po nating tandaan ang mga importanteng mga termino. The slowing down of time as seen by an observer relative to a reference frame. Right. So, ito po yung jumbled words. Okay, so ano po ang correct answer for this question? All right. Answer is time dilation. Speeding of moving object with direction. All right. Ang tamang sagot po ay velocity. The change in velocity of moving object. All right. Correct answer is acceleration. All right. May viewer po tayo na nakakuha ng tamang sagot. All right. Jessica Pablico Bermas. Okay, congratulations. You got the correct answer. All right, next question. A theory that explains the relationship between space and time. Right? The correct answer is special relativity. For the next question, it is the shortening of the measured length of a moving object relative to the observer's reference frame. All right, the correct answer is length contraction. Okay, sa ating po mga viewers, pasensya po kung hindi ko agad na acknowledge ang mga tamang sagot niyo po kasi there is some sort of a delay, I think. Well, anyway, let's continue with the topic for this afternoon. So simulan po natin ang ating paksa sa paghahambing kung ano ang nagagawa ng bigat ng ating katawan every time we go to our bed mattresses, every time humihiga tayo. So isipin po natin na tayo ay pagod na pagod galing sa trabaho at ang pwesto, ang pwesto na agad pinupuntahan natin pagdating sa bahay ay ang ating kama na kagaya ng nakikita nyo po sa inyong mga screen. Dahil sa taglay na lambot ng ating bed mattresses ay talagang mas pipiliin nating mahiga dito kaysa sa kama na walang bed mattress. So, our weight pushes the mattress downward. In Einstein's general relativity theory, our weight which pushes down on the mattress can be compared to the general relativity theory of Einstein. All right. Let us review the two postulates of the special relativity theory. So sa special relativity theory, the first postulate is the relativity postulate. So ayon po dito, all laws of physics are the same in all inertial reference. So nakaupo ka man, nakatayo, o kaya nasa loob ng eroplano o kotse, the laws of physics remains the same. Para mas malinaw po kung bakit pareho ang laws of physics sa postulate number 1, let us use the passenger inside the airplane as an example. Imagine yourself, you are taking a plane to your destination. Sa mga nakasakay na ng eroplano, you may want to go to the comfort room before the plane takes off. Take note, hindi pa lumilipad ang eroplano. You can walk like you are walking outside the plane. When the plane takes off, you have to put on the seatbelt because the plane is still accelerating. When the seatbelt's indicator is turned off, pwede na pong tanggalin ang seatbelt and you go to the CR. So when you go to the CR, while the plane is flying, wala pong pagkakaiba sa feeling when you are walking on the ground and while you are walking on the plane, while the plane is flying at a constant speed. So that's what postulate number 1 means. So for postulate number 2, the speed of light postulate, the speed of light in a vacuum is always the same. So it is always constant at 299,792,458 meters per second or 186 miles per second if it is in the vacuum of outer space. Pero bahagya pong nag-iiba ang speed of light when it travels through some medium such as water, air, or let us say diamond or glass. All right. So general relativity, it is a theory of space and time. So this theory was published by Albert Einstein in the 1915. Iba po ang general relativity theory kaysa special relativity na paksa po natin noong nakaraang linggo. So in the general relativity theory, the central idea is that space and time are two aspects. Okay, so space-time is curved when there is matter, energy, and momentum resulting in what we perceive as gravity. So the curving of space-time controls how the objects in the fabric of space-time moves. Sa kalawakan, ang mga bagay na kagaya ng mga planeta, mga bituin ay may gravitational field that can create curvature in space-time. Ang planet Earth ay may taglay na gravitational field which means it can curve space-time around it. Right? So nakita niyo po sa inyong screen dahil may taglay na mass ang Earth, so it can create a space. It can create a gravitational field and curve space-time around it. So we call this curving of the space-time as gravitational wells na maihambing natin sa isang balong malalim. The bigger the mass of the object, the deeper the gravitational well will be. All right, so okay, spacing, some technical issues. All right. So paano po natin mailalarawan ang space-time sa isang bagay na mas madali po nating maintindihan? Okay, panoorin po natin itong isang short video clip.
Central ideas. So, Einstein wants to know how the force of gravity works, how the sun communicates the pull of gravity across empty space to the Earth. Here's the idea he comes up with. He says that the fabric of space is nice and flat if there's nothing there, no stars, no planets, which would mean that if an object rolls through that environment, say this is a comet or a planet, it will go in a nice straight line trajectory. But the key thing is Einstein says that if we have a heavy, massive object like the sun, Einstein says that the sun, merely by being within the fabric of space, causes the fabric to curve, to warp. And then other objects, like the planets, the Earth, Mars, and so forth, he says, they go into orbit because they're rolling along the curved environment that the sun creates. This, according to Einstein, is how gravity is communicated from the sun to the Earth, to Mars, the other planets. This is how gravity works.
All right. So sa halimbawa po na ibinigay ko po kanina, mahihalin tulad po natin ang space-time fabric sa tela ng kagaya ng nasa video. So if there is a bigger mass in space, so the smaller mass, in our case, ang ating planeta ay pumapalibot around the sun. So if there's no bigger space, so there is no bigger mass in outer space, so smaller mass can just go in a straight line. So if we add a bigger mass in the fabric, so it can create a curve, a deeper curve in the space-time fabric. So how massive or how big the mass the object is, ayun po ang lalim ng ayun po kalalim ang gravitational well, o sa example na nakita po natin, ganun po kalalim ang gagawin na curve sa fabric. And now let us discuss the different consequences of the general relativity. So ang general relativity ay nakafocus po sa gravitation. One of the consequences of the general relativity is the orbit of Mercury. Hello, planet Mercury. Okay, quick facts. So all of the planets in the solar system are named after the Roman gods. In the Roman mythology, Mercury was the quick and agile messenger of the gods. So bakit po pinangalan ng Mercury ang planeta Mercury? Dahil ito po ang pinakamalapit na planeta sa araw at ito rin po ang pinakamabilis makakompleto ng isang buong cycle. So it takes 88 days for Mercury to orbit around the sun at 47.8 km per second. Right. So isa sa mga epekto ng general relativity is the Mercury's orbit. So sa lahat ng planeta sa solar system, ang Mercury ay ang merong pinakakaibang orbit. So Mercury's ellipse, okay, the ellipse as shown in the illustration, so it never close. So para mas maintindihan nyo po, okay, panoorin nyo po itong another short video.
The form of Mercury. Mercury's orbit had been a mystery for decades because it was unusual. All planets orbited the sun in an ellipse. The planet closest to the sun, Mercury, also orbited in an ellipse, but it did something weird. It had something called a precession. What this means is that its ellipse never closes. The point of the orbit that was farthest from the sun advances a little bit every time Mercury goes around the sun. It's as if the ellipse itself is orbiting the sun. No one could ever figure this out using Newton's equations. When Einstein applied his new curved space theory to this orbit, the new theory predicted exactly the precession that Mercury actually has. Finally, a theory perfectly matched the observation, which had been a mystery for decades. You can only imagine how Einstein felt.
Right? So this is the precession of Mercury's orbit. The farthest point, okay, the farthest point away of the planet from the sun, which we call as aphelion, okay, seems to advance a bit every time it goes around the sun, right? Pagaya nito, right? Then, yan. So the aphelion, or the farthest point away of Mercury from the sun, seems to advance a bit as if it goes around the sun. So the same goes with the perihelion. Okay, the perihelion is the point closest to the sun. So kung titingnan po natin ang orbit ng Mercury, ang ellipse niya ay parang pumapalibot po sa araw. Alright, the next consequence of the general relativity is the gravitational bending of light. So our earlier example illustrates that massive bodies can create a curve. Okay, so it can create a curve in the fabric of space and time. And that curving of fabric of space and time, kahit po ang liwanag ay sumusunod sa curve ng space-time o ang gravitational well. Sa illustration, nakikita nyo po sa inyong mga screen ang direction ng liwanag na mula sa isang star na bahagyang bumabaluktot at sumusunod sa curve ng space-time na gawa pa ng isang star. So dahil po sa bending ng liwanag ay nakikita natin ang kinalalagyan ng star sa kalawakan ay hindi ang tunay nitong kinalalagyan. Alright, so we can see here in the in the illustration, okay, this is our perceived position of a certain star when in reality, okay, the actual position of the star is, okay, far away. And as the light bends, time slows down. And as light overcomes the gravitational well, so another effect of the general relativity is the gravitational red shift. Right. So dahil nga po a massive object creates a curve in space-time, so the light will also bend. And as the light bends, time slows down. So as light, okay, light is an electromagnetic wave shown in the screen with the following properties. So it has a crest, a throw, wavelength, and frequency. So the crest, okay, the crest is the the crest is the point on the wave with the maximum value of upward displacement. Okay, this is the crest. And the throw is the opposite of the crest. So when light is undergoing redshift, the wavelength, okay, which is the distance between two waves becomes longer and the frequency decreases. Okay, so that's what happens po every time a light goes upward or tries to escape the the gravitational well. Okay, balikan ko lamang po itong itong slide na ito. Okay, so when light follows the curve and then it tries to make its way out of the gravitational well, so dyan po nangyayari ang gravitational red shift. Right? So, in gravitational redshift, kapag gumahaba po ang wavelength, the frequency becomes lower. So, from shorter to longer wavelength will result to lower frequency. Then another result of the general relativity theory are the black holes. Ang larawan na nakikita nyo po ay ang tunay na imahe ng isang black hole. So the black hole is one of the life stages of the star. So it is the later stage of a life of a star. May taglay po itong hindi kapanipaniwalang mass. So it has a very unbelievable mass. Because of its very big mass, meron po itong napakalakas na gravitational field. Sa sobrang lakas ng gravitational field, maski maski ang liwanag or even light cannot escape. So black holes are from the collapsed stars that runs out of fuel. Ang isang kutsara na matter from the black hole can be as heavy as the whole Mount Everest. So paano nga pala nakikita ang mga black hole dahil ito nga ay itim? So kapag napapalapit po ang isang star sa isang black hole, all of the matter from that star gets sucked into the gravitational field of the black hole. So in every galaxy, there is a black hole at the center. So our galaxy, the Milky Way galaxy, has a very massive black hole at its center. So all of the stars within the galaxy follows an orbit around that massive black hole at the center of the galaxy. So that means that our solar system, which is within the Milky Way, also revolves around that center. So that supermassive black hole at the center of the Milky Way galaxy is called Sagittarius A. It has a mass of equal to 4 million suns. So mahihigo po ba ang ating solar system ng black hole? So the answer is, okay, we are very far. Masyado po tayong malayo. So how far are we from the black hole? 25,000 light years away. So that means that the light coming from the center of the galaxy reaches the solar system after 25,000 years. So masyado po siyang malayo. At the start of our session, so we had mentioned that the mass of an object can curve the space-time fabric. Dahil nga po napakalakas ng gravitational field ng isang black hole, para pong balong malalim ang curve na ginagawa ng black hole. Okay, it can create a very deep gravitational well. So nothing comes out of a black hole. No light, no radio wave, or whatsoever. So even light cannot escape when it go past the event horizon. So what happens beyond the event horizon? So nobody knows. So physics has never been able to answer that question yet. Another consequence is the gravitational wave. So in the illustration, a gravitational wave can be created when, okay, example, a supernova, big stars orbit each other, masyadong malalaking mga stars that orbit each other, so it creates a gravitational wave. And lastly, when black holes orbit each other. So dalawang black hole po, pinapalibutan nilang isa't isa, and when they get closer, they merge. So it creates a very powerful gravitational wave. So a gravitational wave from 1.3 billion years ago were detected on 2015 by the instrument called Laser Interferometer Gravitational Wave Observatory, or LIGO. So this, as I have said, this first gravitational wave happened when two black holes crashed into each other. So it happened around 1.3 billion years ago, but the ripples did not make it into Earth until 2015. Right. And now we'll proceed to the next topic. Sandali lamang po. Right. Yan. So now we discuss the last module for the second quarter. So we're going to discuss the theory of the Big Bang theory. So this is how we know that we are living in an expanding universe. So it was Father George Lemaître, a Belgian astronomer, cosmologist, and a Roman Catholic priest, formulated the Big Bang theory. Ayon sa kanya, ayon sa theory ito, nagsimula ang universe sa expansion. Okay. Expansion ng isang napakaliit na superatom that expanded into the universe that we know today. Napapaloob po sa graphic na ito ang buong kasaysayan ng universe ayon sa Big Bang theory. So according to this theory, the present universe as we know it, started 15 billion years ago. So 15 billion years ago, nagsimula ang universe bilang isang singularity. So the universe began as an infinitely hot and dense singularity, infinite. So hindi natin alam kung gaano ba kainit o gaano ka-dense ang singularity at that time. So all of the matter, space and time are concentrated in that single point. So before time, it was nothing but just nothingness. Then, in a few nanoseconds from the beginning of time, the universe expanded rapidly in what we know as inflation. So in the period of inflation, space expanded faster than the speed of light. Kaya sinasabi na exponential ang expansion ng sinaunang universe. In the human perspective, everything happens so fast. So napakabilis po ng mga pangyayari. So it all happened, nanoseconds. So gano kabilis? 10 raised to the negative 36 power of a second. So mas mabilis pa ito kaysa pagpikit ng ating mga mata. So nagsimula pa lamang mag-expand ang universe. So it was still very hot and dense. And in that period, matter and antimatter were formed from energy. So these are quarks. Quarks and antiquarks. So matter and antimatter, or quarks and antiquarks, were formed, but they keep on destroying each other, in which we refer to as the annihilation. Then one second after the Big Bang, the universe expanded 100 million times than its original size. So in only 1 second, the exponential expansion of the universe has resulted in it expanding million times than its original size. Then as the universe expanded, bahagyang lumamig, the universe cooled down from its very infinite temperature, and finally, the quarks can come together to form neutrons and protons. Then 3 minutes after the Big Bang, so these protons and neutrons form the light elements by nucleosynthesis. So after forming, after these neutrons and protons undergoes nucleosynthesis, hydrogen and helium were formed. And later, electrons bind to these ionized protons and neutrons to form neutral nuclei in a process that we call as recombination. So when these when these protons, neutrons, and electron form together, they form a neutral atom. And because this atom no longer scattered photons, okay, light and energy can now freely move across space in what we refer to as the dark ages. So bakit po tinatawag nating dark ages? Dahil at that time, okay, there were no stars formed yet. Wala pa pong stars na po-form during that dark ages of the universe. Then about 400 billion years ago, after the events, the initial events of Big Bang, so stars, stars and galaxies are formed. So how are the stars and galaxies are formed? Of course, gravity. So the gravity caused the atoms of hydrogen and helium to collapse onto one another and ignite nuclear fusion. So as more galaxies were formed, the universe has expanded further. May mga katibayan po na sumusuporta sa teorya ng Big Bang or the Big Bang Theory. So iilan po sa mga ito ay tinatawag nating the relative abundance of the element. So itong mga light elements na ito gaya ng hydrogen at helium, okay, these were the first elements that were formed during the first stages of the Big Bang or moments after the Big Bang. So the universe ordinary matter composed of the following: 24% helium, 75% hydrogen, and 2% of other elements. So why only the light elements are formed during the early stages of the universe? All right. So it is because the heavier elements like iron are formed in the core of the stars. And these elements are only dispersed across the universe during a supernova explosion. Okay, the other evidence supporting Big Bang is the energy left as a result of the recombination of the positive nuclei and the electrons, which we call as the cosmic microwave background. So the thermal radiation, okay, left by the recombination is seen as a faint microwave glow emitted in outer space and can be detected by the instruments here on Earth. May ilan pong misconceptions associated with Big Bang. So let us clarify some of these misconceptions. Right. The Big Bang is the beginning of the whole process, called the Big Bang model. So ang Big Bang is ang pinakaunang mga moments or the start of this whole process. And Big Bang is not an explosion. Hindi po siya pagsabog, but rather Big Bang is a rapid inflation of space itself. So it is the exponential expansion of space during the first moments of the universe. So that is Big Bang. Hindi po siya pagsabog, as what the term implies. The Big Bang theory does not explain what caused it. So it offers no explanation as to what caused it or how this singularity came from. So after all, this is still a theory that is still a work in progress. And scientists up to these days are still finding evidence for it until now. Right. Maraming salamat po. Maraming salamat po sa ating mga viewers. Maraming salamat po sa DepEd Edtech Unit. Para sa bata, para sa bayan. Kita-kita po tayo sa susunod na quarter. Maraming salamat po sa pagsubaybay sa ating oras, 4 to 4:30 sa asignaturang Physical Science sa Senior High School. Hanggang sa muli po. Ito po ang inyong lingkod, Tutor Lester, na bumabati sa inyo ng magandang hapon. Paalam!
Sigurado ako na marami ka na namang natutuhan sa ating ETULay tutorial session ngayong araw. Tandaan, ito ay hindi lamang para sa ating mga mag-aaral, kundi pati rin sa ating mga minamahal na guro at mga magulang na kaagapay natin para maituloy ang pagkatuto sa kabila ng nararanasang pandemya. Patuloy ding sumubaybay sa DepEd TV para sa mga araling ginawang video episodes. Mapapanood ito mula Lunes hanggang Sabado, alas 7 ng umaga hanggang alas 7 ng gabi sa inyong mga telebisyon. Abangan bukas mula alauna ng tanghali ang iba pang aralin sa ating ETULay free online tutorial session sa English. I-like and subscribe at manatiling nakasubaybay sa ating ETULay tutorial session sa DepEd Edtech Unit FB page at Educational Technology Unit channel sa YouTube at sa DepEd Tayo at DepEd Philippines social media accounts. Paalam!